am Fahira. I would like to talk about dream and how it happens. Dreams are the most remarkable experiment in psychology and neuroscience, conducted every night in every sleeping person. They show that our brain is connected from the environment can generate by itself an entire world of conscious experiences. The study of dreams and dreaming has made remarkably slow progress over the past century due to the difficultness on measuring it. When someone is asked, "What did you dream of?" most of the answers are almost always unreliable. I would like to start with the definition of dreaming. The term dreaming itself is poorly defined, and there is no consensus on the definition. Scientists have eschewed the use of the term dreaming and sleep meditation altogether. Sleep meditation is defined as all mental experiences, including perceptions, thoughts, and emotions, occurring during sleep. To understand how dreams might be produced and the function they may serve, it is important to understand the sleep stages. There are two major types of sleep. The first, rapid eye movement or REM sleep, occurs in approximately 90-minute cycles and alternates with 4 additional stages known as non-REM sleep. The second type of sleep, slow wave sleep, is the deepest of the non-REM phases and is the phase from which people have the most difficulty being awakened. REM sleep is characterized by low amplitude fast electroencephalographic or EEG oscillations, rapid eye movement, and decreased muscle tone, whereas slow wave sleep is characterized by large amplitude and low frequency EEG oscillations. These stages change, relate to, and are caused by neurochemicals like dopamine, noradrenaline, and serotonin that are having fluctuations during sleep. Typical REM and non-REM dreams are quite distinct, particularly with respect to episodic memory content. Episodic memory refers to knowledge about the past that incorporates information about where and when particular events occurred. It is typically contrasted with semantic memory, which consists of knowledge like facts, word meanings that has been uncoupled from place and time existing on its own. When examining REM sleep dreams for memory content, one finds that episodic memories are rare and typically emerge as disconnected fragments that are often difficult to relate to waking life events. These fragmented REM dreams often have bizarre content. For example, the normal rules of space and time can be ignored or disobeyed, so that in REM dreams it is possible to walk through walls, to fly, interact with an entirely unknown person as if she was your mother, or strolling through Paris past the Empire State Building. Non-REM dreams, however, are quite different. Non-REM sleep, particularly slow-wave sleep, has been associated with sleep-dependent improvement on a range of hippocampus-dependent tasks in semantic memory. Here, episodic memories do appear in dream content. Recent episodes are predominant, but remote memories occasionally appear as well. This pattern of results suggests to us that the memory systems needed to generate complete episodic retrieval are functional in non-REM sleep, but not in REM sleep. That's what makes REM dreams are more bizarre. So, how does dream happen? Dreams reflect our interest and personality, just like mental activity during wakefulness. Formal content analysis has revealed that mood, imaginativeness, individual of interest, and predominant concerns are correlated between our waking and dreaming selves. Personal anxieties we experience in wake state, such as being inappropriately dressed, being lost, or being late for an exam, can appear in dreams that involve social interactions. Dreams, like our personality in general, are quite stable over time in adulthood and share many characteristics across cultures. In addition, we feel we are personally participating in many dream events. Specifically, dream construction does not include the veridical replay of complete episodic memories, whose recall is normally mediated by the hippocampus in waking life. Instead, Dreams appear to be constructed from unborn fragments of various recent episodes, intermixed with remote memories, semantic memories, and representational memories, all stored in and directly accessible in the neocortex. Now, when we talk about dreaming and its underlying neurological changes, it is really difficult for researchers to figure out where dreaming actually arises from in the brain. The dreaming itself is pretty much independent of any kind of external stimuli. A researcher can do something to a dreamer to try and start or to stop the dreams. They just have to wait and see if it happened or not and hope the person that is dreaming give them a proper account of what happened. Let's recall again to the kinds of dream that we get during REM sleep phases, because these are the most clearly defined in terms of what part of the brain are actually activated. The parts of the brain that are activated actually correspond to subjective experiences of dreaming, vivid imagery, and storylines. Positron emission tomography or PET scans show that the whole brain metabolism is actually really similar during REM sleep as it is to when you are awake. And EEG signals during REM and wakefulness are also really similar. Despite this, there are several parts of the brain regions that are particularly active during REM. These include the occipital temporal visual association areas and this is probably why we get such a vivid visual imagery in REM dreams. There is also high activity in the primary motor and premotor cortex as well as the cerebellum and the basal ganglia. This probably account for movements during these REM dreams. The other important structures to know about are the pontin, tegmentum, the thalamus, the basal forebrain, and the limbic structure, specifically the cingulate cortex, the hippocampal formation, and the amygdaloid complex. Now, these all parts of the brain together are really important for emotional processing, and they are probably responsible for the really intense emotional aspect of REM dreams. There is also increased activity in other areas like medial prefrontal cortex or the medial temporal lobe and posterior cingulate cortex, which implicated in memory and self-referential processing. So there is obviously quite a large proportion of the brain that becomes active during REM sleep. Interestingly, during REM sleep, there are parts of the brain that are not very active, which giving us really dreamy qualities that we experience. The right inferior parietal cortex is really turned down. This part of the brain contributes to representing ourselves or comparing ourselves to other things. The part of the brain that are really important for cognitive control and orienting us in time, place, as well as testing what is in front of us. These are all in dorsal lateral prefrontal cortex, and the orbital frontal cortex also turned down. And that's why we can't remember our dream afterwards. So, those are the parts of the brain that are either REM up or turned down during REM sleep. Now, how about non-REM dreams? When people are awakened from non-REM dreams, decreased low frequency and increased high frequency power are happening in both parietal and occipital lobes, including the medial and lateral occipital lobe, as well as the precuneus and posterior cingulate gyrus. The last question, why do we dream? The most accepted theory of why we dream is that when we sleep, we are trying to reactivate and consolidate memories, essentially trying to compartmentalize new things that we have learned. Waking consciousness is more like watching news in real time, while dreaming is more like watching a movie created by an imaginative director. As in some B movies, the director is not particularly choosy, and any actors, dress, means of transportation, or objects that is readily available will do. Albert Einstein once said that imagination points to all we might yet discover and create, and indeed, dreaming may turn out to be the purest form of our imagination. Thanks for watching.